Hey guys, so in this one we're going to find the Cobb-Douglas production function's corresponding cost function. From the first video, we defined the cost function as the solution to this problem. And this one, both of these are differentiable, so we can use a Lagrangian. So we're going to have x1, x2, and 1 lambda because there's one constraint. So this is going to be equal to p1, x1 plus p2, x2 plus, and we're going to do, this is going to be our g, this is going to be our b. So we're going to do lambda y minus x1 alpha, x2 1 minus alpha. And here, I'm not going to assume anymore that my constraint's binding because we can use the Kuhn-Tucker FOCs to show that it will be. So the first order conditions that we have are going to be the derivative with respect to both of the x's is going to be 0. So we have p1 minus alpha lambda x1 to the alpha minus 1, x2 to the 1 minus alpha. It's going to be equal to 0. And also p2 minus lambda, or I guess, sorry, minus 1 minus alpha lambda x1 alpha, x2 to the negative alpha. Both of those are going to be equal to 0. Also, we have lambdas greater than or equal to 0. We have y minus x1 to the alpha, x2 to the 1 minus alpha less than or equal to 0. And we have that their product is exactly equal to 0. So right away, what has to be true if this is equal to, if it's greater than 0? Or sorry, less than 0. So what has to be true if this is holding with a strict inequality? If this constraint does not bind? That would mean lambda has to be 0 to make this product 0, which would mean we would have this term would be 0, this term would be 0, so we would have p1 and p2 are both 0. Obviously that can't happen, so we know that our constraint is binding. We know that this is going to be a strict equality. So we can draw that equality and get rid of these two conditions and proceed from there with the algebra. In theory, there we go. So there are a few ways to do this. One of the ways, I like to do it is, let's do p2 over p1, and that comes from moving this and this to this other side here algebraically. So you get p2 over p1 is going to be equal to 1 minus alpha times lambda x1 alpha, x2 to the negative alpha, all divided by alpha lambda x1 alpha minus 1, x2 1 minus alpha. You can simplify this by getting rid of these, getting rid of these, and getting rid of these. So now what we're going to have is 1 minus alpha x1 over alpha x2. So equivalently, we have x2 equal to p1 1 minus alpha x1 over p2 alpha. And now you can put this back here. And you get y minus x1 alpha times this whole thing to the 1 minus alpha equals 0. And so if we solve this term, we're going to get what x1 star has to be, and then we'll also have what x2 star has to be. So y is equal to x1 to the alpha times p1 minus alpha over p2 alpha to the 1 minus alpha times x1 to the 1 minus alpha. So we can add these two together, these exponents, and we get y is equal to p times 1 minus alpha over p2 alpha to the power of 1 minus alpha times x1. So finally, x1 star, the optimal value, is going to be equal to y times p2 alpha over p1 1 minus alpha to the 1 minus alpha. And I flipped the top and bottom here when I moved it to the other side. So that's our x1, and we can put that in right here to get our x2. So it's going to be x2 star equals this thing times p1 1 minus alpha over p2 alpha. I forgot already. p1 1 minus alpha over p2 alpha times y times p2 alpha over p1 1 minus alpha to the 1 minus alpha, and again can add these exponents. And you get this to be equal to y times, sorry, let me be more clear. This is equal to p2 alpha over p1 1 minus alpha to the negative 1. So when we add the exponents, we're just going to be left with a negative alpha. So that's what I meant by that. Equals y times this ratio to a negative alpha. And that's our x1 and x2. Let's copy these onto the next page. And then finally, we want to plug these back into our objective function to figure out what our cost actually is. So we'll do p1 times x1. So that's going to be p1 times this term plus p2 times this term. And that's going to be the cost function given y, p1, and p2. And that's how you work this cost function. Now, I take no responsibility for if the algebra is wrong. I just wanted to work through a problem start to finish to show you how I would do it. So as you can see how the amount of consumption is going to change as the price of the two goods changes. And that's an exercise to you, is to think through this. What is a price one increase going to do to the consumption of x1 and x2? Sorry, not the consumption, the use of that in the production. So, hope this is helpful, and I wish you guys best of luck on your exam in the morning. And I leave you guys with this elephant.